So on page 14, it says, hey, what's the slope of the line tangent to this curve? And again, arctan we can just rewrite as what? Yeah, tan to the -1, which is just inverse tan. You don't have to rewrite it like that. I just think it helps me. And what's the slope? So slope, we got to just find the derivative. You know it. Inverse tan is my favorite one. There's no square roots and there's no negative signs. So what's my u in this function? 4x. You know it. So we're going to say 1 over 1 plus 4x quantity squared, or you might say 16x squared. I don't care. Which one do you guys like to do? 4x, square it? Yeah, because then we might make mistakes when we simplify it. Okay. What are we missing? Bless you. Times the derivative of 4x, which would get me 4. Could I just do this? Yeah, because that's going to be the same as that. I dig it. You guys, they want that slope when x is a fourth. They want that slope when x is a fourth. So I'm going to do my cute little when x is a fourth evaluation bar. And that just means letting the reader know. I'm going to plug in a fourth right there. I'm going to scroll this up so that we can see. I'm going to plug in a fourth right there. So I've got 4 over 1 plus 4 times 1/4 and square it. What is 4 times a fourth?
1.
Yeah, you know it. 1 squared? 1. So what do we have here? 4 over 2 is going to get me 2. He just said, why is there a 4 on top? Yeah, because that's my du dx. Oh, right. The derivative of my u. You could have put it at the end, but I just did 4 times 1, got me a 4 on the top. Yep, good question. I want to skip 17 for right now. We're going to do it next. I just want to do 20 first. Get our brains going in the right direction. You guys, this is saying, hey, what if they want dy dx of arctan of cosine of x? You guys, this is my u. Because again, if you want to rewrite it, this is the same as inverse tan of cosine of x. I love that inverse tan. I love it because it doesn't have any negatives or square roots. What do you think, y'all? What's my dy dx going to be? dy dx is 1 over, what do we got? 1 plus, then what? Cosine of x squared. Make sure that it's either in parentheses or written fancy like this. What do we multiply this by? The derivative of cosine. Derivative of cosine? Negative sine. Boom. Is that an answer? Hey, I love that. Here's the last one. You guys, what does this thing look like? Yeah, this is that formal definition of the derivative. And look what they said. It is 2. They want us to figure out the value of a. So let me remind you what that formal definition of the derivative looks like in this form. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. Whew. So do you agree they're looking for the x coordinate that we're taking this derivative of? Can anyone tell me what my function is? What they're asking for is what's the function, what's the derivative of that function, and what's the derivative at a certain point. Anyone tell me what the function is? So good. It's going to be the inverse sine of x, because you're right. They want us to know, they want to tell us to find out what that a is. So my function is just the inverse sine, and we're going to say of x. Awesome, Mags. Yeah, we could put an a there because of how this question is worded. You guys, what's the derivative of inverse sine? We got to go use our fancy rule. Inverse sine would be 1 over, what do we got? Yeah, 1 minus x squared. You okay with that? Okay, and look what they asked you guys. And yeah, to Margie's point, x is just an a. I could have left that as an a. They said the derivative, because this just means the derivative, is how much? 2. It equals 2. We got to go solve for when this derivative is 2. Yeah, Jay, bro. And in this case, we haven't seen one like this. They're saying, when does that derivative equal 2? Now they're asking us about algebra. Now they just want to know, can you use algebra to solve this equation? What would you guys want to do first to solve? Oh my gosh, my pen is just not happy with me. What do we want to do first to solve that equation for x or for a? Exactly. Let's get that root on both sides. So we got multiply by 1 minus x squared square rooted, 1 minus x squared square rooted. When you do, cancels out of that numerator and denominator. And we're left with 1 equals 2 root. What are we going to do next to get my x? You got it. Let's divide by 2. We got 1/2 is my root. You know it. 1/2 squared. 1/2 times 1/2. You know. Square root squared. Cancels out. We're getting close, people. You want to add x squared or subtract 1 first? I don't care. Okay. 1/4 minus 1. 1/4 minus 4/4. Negative 3/4 is negative x squared. What are we doing with those negatives? Just get rid of them. Can I say divide by a -1 would make them both positive? Final answer. Got to square root both sides. And I'm left with x is the big old square root of 3/4, which is equivalent to saying, oh, square root of 3 over square root of 4. Why might I do that? Yeah, she's saying, all right, well, on the bottom, I can have a 2 down there then. And I heard someone say, it's B. Okay, so this 3/5, we're just talking about, I've taught you 3 different rules. The product rule, the quotient rule, and the chain rule. And now we got to figure out, when do I use which? And that was kind of what our little quiz was on. And I think that's where some confusion came from. So do you agree, a product rule, and maybe we want to just zoom in on that. What's going on between F and G? They're being multiplied, right? So I'm just going to put like, boom, that's being multiplied in there. Or you could say like multiplied, whatever you want to do. Multiplied. I just put way too many I's in that word. And then did I give you the rule? Did the version of this textbook's rule look a little different than ours? What's this part? Isn't that the fig plus the, doesn't matter? So maybe underneath you just want to say, okay, that version's fine, or I'm used to fig plus gif. Whichever. They're the same thing. That quotient rule, we got division going on, yeah? Did they really do low D high minus high D low all over low low? Do we want to write down the rule maybe? Maybe you want to, maybe you don't. If you're like, dude, I got it. She's got it up there for me. You could do either. I'm just going to put it up just so it's there. dy dx is low D high minus high D low all over low low. Math, all we're doing in 3/5 is just figuring out, seeing the 3 rules that I've taught you and when to do each of them. So it's just some practice. And then what's up with this chain rule? What do I have in here? F is the outer and G is the... So again, maybe we just do that little, just remind ourselves, that's my outer, this is my inner. And maybe you write words to this. What is F prime? F prime is the derivative of the outer. What's my G? Yeah, leave the inner. And then what do we multiply that by? The derivative of the inner. Again, you do not need to write any of these, but it might be helpful to some people. It says sort the following. I gave you, 9 different equations. Let's sort them. Which do we think needs to use? Let's go with, you guys tell me. We don't have to go in order. Anyone have any idea what any of these 9 might require using? What's that one going to require? Quotient rule. Could I rewrite it to not require quotient rule? How could I rewrite that? Yeah, so I actually put that over here, meaning you could use quotient rule, but if you can see that that's the same as y equals 3x to the -4th, what would that derivative be? Beautiful. You can end right there. Was that faster than doing low d high minus high d low all over low low? Yeah, but you could have done quotient rule and it'll get us the same answer. Okay, so I've done that one. We did it. What about this guy?
Seems like an inner outer.
Ooh, I agree. This part, this guy has an outer and an inner. What's going on with that x? It's being multiplied by that outer and inner. So you're not wrong. It's just like, what else is going on, right? So maybe we go like this. Boom. There's like a multiplication sign there, right? So now we're going to put that under product rule. And we got x times the inverse sign of x. Let's go practice taking that. What is the derivative? And you're like, okay, that's one function being multiplied by another function. We got to go do fig plus gif. What would f prime be here? 1 times inverse sign, right? Because that's just going to be my f prime g. Yeah, I know, right? We want to do more than one derivative at a time. Plus, now you're right, row. Now g prime is going to be, see if we can do it without flipping back over.
1/√1 minus x squared.
Times the derivative of my x. Great. I'm not even going to write it, right? Does that sound good, Ken? Yep. So that's my g prime. What do we need to multiply that by? X. Could I go like this? And throw that x just right up top? Sure. And we're going to call it good. You guys, which of these, let's just go in order. Do we see one that we're going to need the quotient rule for? That guy? Okay, so I agree this one's like, all right, we should go quotient rule. I'm going to show you something. Don't write this down. Could I have rewritten this? Don't write this down. Like this, e to the 2x plus 3, all that to the -1. Could I have brought that up by taking it to the -1? And I'm here to tell you, yes, I could have. And then you're like, okay, so then we don't need quotient rule. I agree. But does this make this better? What rule would I need to use? What's going on between sine of x and e to the all this? We're being multiplied, right? So I'd have to use product rule. So I'd have to do fig plus gif. What about this function? Doesn't this one have an outer and an inner? Like, that'd be gross, right? So I'm here to say, even though we can rewrite it like this one, we rewrote, and life was so much easier than the quotient rule. Even though you can rewrite it, doesn't mean you always should, okay? This one, yes, we could do product rule. It's just going to be gross. So you're like, okay, let's just go with what it looks like, and let's go use that quotient rule. Let's do it. So we got sine of x over e to the 2x plus 3. All right, y'all. dy dx. We got to do low d high. What's my low? Yes. D high. What goes next? What sign? Sorry, add or subtract. Yeah, always do whatever this looks like. That looks like a minus sign. That looks like a minus sign, a big division sign. So we got to do minus. Low d high minus high. Be careful on this low, you guys. Be careful. E to the 2x plus 3 times something. This has an outer, very good, and an inner. You took the derivative e to the anything is e to the anything. We have to multiply it by the derivative of that anything or the derivative of my exponent. Very easy to forget. Does that get us a 2? All over e to the 2x plus 3 squared. All over low, low. To your point, Ev, didn't you agree we just had to use the chain rule? But that was within this bigger quotient rule question. Is there one that we just see an outer and an inner? So I'm going to cross this guy off. Do we see one with an outer and an inner?
The one right over basic rules.
Basic rules. Yes, you're saying this guy? I dig it. I'm going to rewrite it a little easier. What would be my outer? Yeah, something to the 1/3, right? 4 minus x squared to the 1/3. That's got an outer and an inner. Let's go find that derivative of that outer. What's the derivative of my outer going to get me? I love it. She's saying take the derivative of the outer. 1/3 minus 3/3 would get me negative 2/3 would be my derivative of the outer, and I'm going to leave my inner. What are we going to multiply that by?
Negative 2x.
You know it. That's the derivative of the inner. We're done. Do you see another one that requires chain rule?
Y equals e to the 10.
Yeah. He's so right. I'm going to do this. Y equals e to the tan of x. What's my outer there?
10 of that.
Careful. E. E to the tan of x. Because I left my inner, what am I multiplying that by? Ooh, derivative of the inner, derivative of tangent. Yes. Secant squared. You're done. I see another chain rule. I see 2 more chain rules.
5x ln.
What's happening between my 5x and my ln of x? They're being what? Yeah, let's go do product rule on that. Y equals 5x times ln of x. And maybe it might help you to read it out loud. Like to say those words, I don't know. Okay, what do we have to do if I've got 5x being multiplied by natural log of x? Fig plus gif, I heard it. What would f prime be? 5. What do I multiply it? What's my g? F prime times g? Love it. Plus g prime, derivative of natural log. So good. 1 over x times the derivative of my x. 1. Good. What do I have to multiply that by? F prime times g plus g prime times 5x. I don't care about simplifying. Whew.
Y equals ln of 5x squared plus 1.
Is going to be a chain rule. So good. He's saying this guy up here, it's going to be a chain rule. So he's saying I got an outer natural log and I've got an inner 5x squared plus 1. Awesome. Good row. What's the derivative of that outer? What's the derivative of natural log of anything? Yeah, 1 over the what? Nice. 5x squared plus 1. You always put that whole quantity in there. But then we got to make sure that we're multiplying it by 10x. Geez, there's a lot of these. There's a lot of these. Okay. What do we want to do with this guy? Yeah, let's go quotient it up. Let's go quotient it up. So on that guy, I got y equals e to the x divided by sine of x. Low? D high. Nice. Times the derivative of x. Good. Low D high minus high D low. All over.
Sine squared x.
Love it. I love how you said that too. Sine squared x. Throw that squared in between. That's good. That's good. And we have what? 2 more? What's this guy going to be? Geez, oh man. Just to let you know, if you're running out of space, you could just draw a little arrow. This is also chain rule, and it's going to be inverse cosine of 2x plus 3. Inverse cosine, gross. Starts with a C. Will it be positive or negative? Negative 1 over square root or no square root? Square root 1 minus. Yeah, I better put that in parentheses, right? That's my u. What do we have to do to it? Square it and then multiply by the derivative of u. Could I have just put that as a negative 2 up top? Sure. But this is fine too. Whoa. Then I just left one last one.
Basic.
Yeah. You're like, oh, okay, this one doesn't look too insane. E to the x plus 3 sine of x. Just so you know, this is like what we started with. We have no chain rule and things built in. What's the derivative of e to the x? Yeah. What's the derivative of 3 sine? 3 cosine. We're going to skip the top one. Look at this guy. My question is, it says, in what order should we apply the rules of the derivatives? Write the rules in order that you apply them, then take the derivative. I want to do that first one especially. What do we got to do first? Yeah, we got to go do that chain rule because I've got an outer E and then I've got an inner x times the sine of x. What's the derivative of that outer? E, love it, to the. Right, love it. Thanks, Frederick. And then, what's the derivative? What do we have to do with that inner? Kind of. What's going on? We got a what? He's like, what word is, yeah. Yeah, what's going on between x and sine of x? They're being multiplied. So now I got to do the product rule. Ugh. Okay, we got to do a little fig plus gif. What is f prime? Good, times g. Cool, so I'm just going to say sine of x, because 1 times sine of x is sine of x. Plus g prime. Yep, times x. You guys agree that this might get a little wonky looking? Some people might be tempted to say that that's cosine of x squared, because that was g prime times f. So you're going to see like a textbook would always throw that right in front of it. It's the same thing. If you leave it in the back, that's fine. But you just might see it that way, okay? Okay. Let's take a peek at that next one. What do we see first? What's going on between these things? Yeah, we're seeing multiplication, right? So we got to go do that product rule. What is f prime? Yes, g. Sine to the 5th, sine of x to the 5th. Good. Plus, be careful. Isn't the sine of x to the 5th really this? Yeah, what does this guy involve? Chain rule. We got an outer and an inner. So now we got chain rule that we got to do. What is the derivative of this outer? 5. Leave the inner. Bring that exponent down to 4. I'm going to specify what we found here. This was f prime times g. This is g prime times f. I'm not done with my g prime though. Taking the derivative of the outer, I left the inner. What do we need to multiply that by? Yeah, which would be cosine. And then we got to say times f. F prime times g plus g prime times f. Where do we get this guy on the end?
Oh, that is that. Never mind.
That's okay. So again, all I want to do today is just practice these processes, you guys. we've got the derivative arctan of e to the 2x. Derivative arctan of e to the 2x. And again, some people, it might help to just rewrite that as inverse tan of e to the 2x. You don't have to. Does anyone remember derivative of inverse tan? 1 over 1 plus e to the, oh yeah, u squared, agreed. And my u in this case is e to the 2x, right? Squared, you just said. This is the easiest part to forget. The derivative of my u. The derivative of my u. Do you agree my u has an outer and an inner? So many layers. This is a peanut M&M for sure. What's the derivative of e to the anything? E to the anything times 2. Very good, you guys. Is that an answer?
Probably.
I agree it's not D or E because we got a lot going on up top. We got a 2e to the 2x on top. Oh, and then 1, they're trying to tell us that we're sign with that square root. Nah, we feel good that when we have a power to a power, you multiply them. 2x times 2 would get me 4x. Good job. This is a lot, you guys. This is a lot. Whew, I just threw this in here. I got a y randomly in my equation.
Wait, on the last one,
Yeah.
why is it not squared on the bottom?
Down here, good call. They went ahead and simplified it. E to the 2x squared means e to the 2x times e to the 2x. And when you've got my exponents like that, we've got matching bases, you could add them. 2x plus 2x is 4x. That's where they got that. Or you could just say power to a power, we multiply. 2x times 2 would get me that 4x. Yep. Good call. Anyone? What are we doing when we have a natural log? 1 over the 2x plus y. I'm nervous about the derivative of the inner here. Derivative of 2x
2.
is 2. Be so careful. The derivative of y.
dy.
Nice, you guys. It'd be 1 dy dx. Awesome. Don't forget the right-hand side. What does that equal? We took the derivative of the left, so we got to do the derivative of the right. 1. You guys, they want dy dx all by its lonesome. We can do it. What might I do to get rid of this stuff?
Multiply by 2x plus y.
You know it. That's in the denominator. Let's multiply it. 2x plus y. Psh, psh. 2x plus y. Psh, psh. Psh. We have 2 plus dy dx equals 2x plus y. Okay, guys, what's my final answer going to be? What's dy dx going to be? 2x plus y. Move that 2 on over. Do we have an answer for that? Woo! Okay, last one then. Last one. Which does not require the chain rule? Which of these does not require the chain rule? Ooh, I almost didn't include this because I think it's tricky. Does this one require the chain rule?
Yes.
Yeah, it has an outer and an inner, so that's not my answer. Does this one require the chain rule?
Yes.
Ooh, an outer and an inner, because that trig function, you're so right. It's a 50-50 shot now. C. Ooh, tell me.
10 and root x.
But what's my inner here?
X.
Right, what's the derivative of x? 1. So do we really have to have it? Because you know what I'm saying? The 1's not going to change anything. But what would require it over here? The y does. I think this is so confusing. What's the derivative? Let's just focus on this one right here. You agree this derivative would be 40x to the 9th. Life is good. What's the derivative of this one? 18y to the 2nd times dy dx. That requires the chain rule because of that implicit differentiation. Now, you're not wrong, Ev, but because this inner was just a 1, it wouldn't. We wouldn't technically need it. Is AP going to ask you this question? No. But is it important for us to remember dy dx on that? Sure.